Okay, hello everybody. Um, I see that mostly all of you are present today. It's not necessarily straightforward, but we'll try to make it as easy as possible if you want. What I would start with first is our new working environment, if you want. Consider that this is going to be probably valid for the next for the end of the semester for sure, but maybe also for the summer term, we don't know yet. So the more comfortable you are with this online delivery of lectures, the better. What I also want to talk to you is in the hope that everybody is safe and sound, that you stay safe and healthy like now, and with time things will get back to a new norm or normal. We'll see. How we are going to continue our course today and for the next 3 weeks. This is what we are going to first figure out. First of all, I would like maybe to set up some sort of a protocol. I see there is among you only one student that is not displaying a camera. So of the 22 students that are recorded in registered in class, we have a good majority here, and I hope you would you'll be able to continue with the regularity going like this. So I was saying about communication protocol. Let's try to do the following. For now, I'm going to mute all
Professor, I can't hear you.
Okay, I'm
Yes.
sorry.
Okay. Yeah.
I was mute somehow. Okay, did you hear anything that I said so far? Because I've been speaking for a few minutes now.
Nothing, actually.
Unfortunately, no.
Yeah.
Good. So I'll start all over again. So I was saying first that I hope everybody is safe and sound, in good health, and you will stay like this. Second of all, we'll have to figure out how we continue our lectures in this format in terms of interaction, because the easy part is for me to record the lesson, and then I'll put it online and you can look at it. But I think it's best to maintain as much interaction as we can with this system, and it's still doable. I see most of you have also a camera, so if you want to use it at some point, anytime, you can use it. What we are going to do to maintain some good interaction and make it easier for everybody, everybody will be mute that is, their mics will be muted. I can do that for all of you at the same time, but you can either raise your hand to send me a signal that you want to ask a question, or you can send me a quick message on the chat window. So either one, you should be able to get in touch by providing feedback, right? So I'll interact with you and see if you have questions or clarifications. Do you have any questions so far? So if you have questions, either unmute your mic and say it, or raise your hand and I will give you the speaking privileges, so to speak. Okay, nobody has no questions. Okay, good.
I have a question actually, sir.
Yes, I'm listening.
I have like a question. I'm kind of worried, like because like regarding our group project, since it's kind of like regarding the current situation, like we haven't been talking too much with the group, and I was worried like how we're gonna present our work since we have a presentation and so on. How is that going to be handled, and the quizzes and the final exam? Like this is gonna be my first online final exam. It's kind of a little bit worrying me. So like I hope.
Okay, I'll clarify this for everybody. First of all, let me figure out this for one of your students, one of your colleagues, not being able to hear us. So I'm going to send them a message. If you ever have problems connecting your audio system to the computer, you can always use your phone number, and with your phone to call a number, and basically this number is in Moodle. You can see it in Moodle as well. When you look at the information about this and if you use the phone, sometimes the connection is even better than the computer. You can even watch on the screen and listen on the phone at the same time, so everybody's convenience. So I was saying that let's take one thing at a time. First, about completing this term, and there are several components here, right? We have the two more quizzes, basically, which we didn't cover. For that, I'm taking the easy questions first, okay? You didn't even ask that question, but I think that it would come anyway. So for that, I'm considering using an online quiz through Moodle. I don't know if you ever used the Moodle quiz through Moodle, but it's a little bit more cumbersome for me to set it up. I will do it. That's not an issue, definitely. Sometimes it may be difficult for me to, not for me, but for the system to assess it. So I'm going to figure out a balanced question set between calculated problems and theoretical questions. Now, what we have to understand here is if we do an online quiz for Moodle, basically this is an open book exam, right? And we want to make sure this is fair and the exam integrity is preserved as much as reasonably possible. And there are ways to do it. So for a test drive, if you want, I would like to use our remaining two quizzes, basically merge them into one. So what I would like to do is to have, I'm going to write here for only one student, maybe that was not able to join yet with the sound. That is quiz. Let me put it like quiz 3 and 4. One quiz on Moodle. So the way this will work, I will set up in advance with you, in consultation with you, a specific, that is a timed quiz, a specific time during which you can take the quiz. So everybody should make themselves available, maybe in the sense that I will put a 12-hour time interval when you can allocate, let's say, half an hour, 45 minutes, depends on the content there, to work on it. So it's a timed quiz. That is, when you start working on Moodle, a timer will be initiated, countdown timer. So you can see the problems. I'll put all the problems, they're not many for a quiz, in one screen page. You can work them out, and there are different ways you can provide input. And once you are comfortable with the input you provided, with the calculations, verifications of your solutions, you just submit the quiz, and the quiz is automatically graded, and you'd have a response. I can set up this response to be available for everybody when all of you finish the quiz, probably the next day, let's say. I'd like to try this to see how it works. I don't think we have time for 2 quizzes, but at least one. That's why I'm going to push it a little bit later to put the content that was initially mentioned in the course outline exactly the same. You have the performance assessment, the performance intersections, performance measures, and the queuing models, both types of problems in one single quiz. So maybe we'll give a little bit more time there, depends on how many problems I can come up with given the constraints of Moodle. And that's one, the quizzes. The other assessment that we have is your project. And I know you haven't been able to work together much in the past couple of weeks. 10 days or so. What I'm considering here is that we cannot really forfeit the project, because that's an important part of your grade. Also, I'm considering the fact that you would be able to interact. The way I'm doing this with you now, you can use Zoom. Okay, or Skype, or whatever other social media networking like we have now. It's pretty much plenty of time available in our hands because of all the restrictions that probably will come even stricter soon by not letting people getting out easily, only with justified reasons and so on. So what I'm considering here is to help you, if you want, to work for the project. In Moodle, I don't know how many of you have other license for Moodle. I meant to say Zoom. For Zoom, other than the basic license. The basic license for Zoom has a limitation in the sense that if you have more than 2 participants, you have more than 2, I believe, or 3. It may be 2 or it may be 3. I have to check this. Then they limit you to the minutes, to the duration of a session. So 40-minute session. You start the session, 40 minutes, they kick you out, then you have to start it again. It may be inconvenient. If you need more than 40 minutes continuous, then I can set up some meeting sessions for you. You give me, there are about 10 groups, if I'm not mistaken, 9 or 10 groups. So I can get in touch with every group leader, if you want, and I can give you a link on Zoom in my account where all of you can meet anytime you want and discuss, share PowerPoint, share files, share information. One of the groups already got in touch with me a few days ago regarding access to Vism. I don't know how many of you are using Vism, and if you still need that help, I can provide you with Vism and any other support that I can be of use. I set up some office hours on Moodle as well. So if you click a link, there is there a link that says office hours, and you can, for one, you can call me. You can we can establish a time where you can discuss if you need help. I believe that you have two more weeks until our last lecture. And during these 2 weeks, what I would advise you to do is to work on the project content and analysis and results, and work on a presentation. The actual project paper, term paper, is not due in 2 weeks. We'll make a due date a little bit later. Maybe we'll give you another week or so to complete it. But at least to have the analysis and the results ready to be embedded into a presentation, a PowerPoint file. And when the time of the lecture comes in 2 weeks, the way I'm going to share today a PowerPoint file with you, you can do the same from your computers. So we'll simply maintain the same virtual format, virtual classroom that is, in which one or two, three speakers take the podium and present the project. Maybe I'm talking a little bit without taking breaks and asking you if you have questions. So far, do you have any questions? Anybody that has questions, you have to unmute yourself and start talking. Try to do it in an organized fashion, not all at the same time. I hope you can still hear me. Okay, if you can hear me, just click on this, and I'll see a yes there next to your hand. Okay, good. Ahmed has his hand high up. Yes, Ahmed, do you have a question?
Doctor, first of all, I mean, the time we have, what I think is, will not be enough actually for quizzes and final and projects. And under these circumstances, actually, it's the most difficult time we have seen in our lives, especially like me, for example. I'm just have 5 kids at home. I just found, a little space here, just escaping from my kids. Actually, it's hard time actually. But how can we, for example, adjust or accommodate this problem? For example, can we, for example, consider the previous quizzes and just take the time the time available for us to work hard or serious in the project to finish it and to have some time for the final exam? I don't know if that's possible or not. At least because if we want to concentrate for quizzes and now for the coming quiz will be two parts as two quizzes together, that will take time, and actually 10 hours at home, okay, like you study 1 hour outside. This is especially for me. I don't know other people, maybe they have everything is okay, but for me it's very difficult and it's complicated actually. Why? Because I was studying outside. This is the first time when I just joined the university. I will study at home. This it's very complicated for me. That's why if we can find a way to, for example, to consider previous quizzes or something like that, to find more time for project and final. And not only for this course, we have other courses also, and all of these the same thing. And for the exam, can we, for example, have an example of an exam on model, or just like an example question to solve it, and just to see how the system will work with us for the real exam. I mean, is that possible? I don't know. This is my opinion. I mean, if we can find a way, I don't know. Thank you, Doc.
Okay, I got this point. Anybody else that has other questions? I'll take them all at the same time if you have. Okay. Sorry.
Yes.
I'm listening, Ahmad.
Yeah. With all respect to my friend, I totally agree with him. But the problem, some of us, like, I'm pretty sure they didn't do well on the first quiz, and so on the second. So it might not be fair for all of us. I'm not talking about myself. That's my only comment. Thank you very much.
That's again something that I thought about. I thought about both your specific questions. Because everybody has a family, more or less different kinds, different setups, and it's not convenient. So, quizzes versus final exam. I understand that it may be a little bit more stressful situation, maybe quite considerably stressful for some. Now, consider that we have one extreme where it says, let's stop here with all the assessments. I can continue with the lectures and say, let's see what kind of grades you have. For some would be advantages, maybe. For some, it won't be, okay? But the fact that I'm taking away from you the chance to improve, it's going to be unfair for all of us. If there is, there is always room for improvement, as they say. Now, an example of a final exam on Moodle definitely would be exactly what the quiz will look like, okay? So I'm going to build this quiz for you to work on. We'll have the opportunity, maybe at the end, to have information about how you perform in the paper quizzes, how you perform in the online quizzes, and I'll try to get the best out of those, okay? So I'm not going to penalize you if you didn't have the opportunity to do better earlier or later. So I'm trying to get maybe the best out of 3, the best 2, the best 1 out of 3. We'll have to look at all this. So I definitely, I'm open, and it's normal that we should consider this situation. Consider that the online, except for the final exam, the online quiz, you can take it anytime within a 24-hour period, right? So if I open it today after the end of the lecture until tomorrow at the same time, then you can choose your time. Maybe you would find a few, better time to work later in the evening, very early in the morning when everybody is still asleep. You would find time, 45 minutes, 1 hour to take all your materials next to you. Remember, this is an open book exam. It's not like in the classroom where you have to remember formulas and everything, right? So you would have access to all those. And I think this would be a very good, as I said, a test drive, very good opportunity to see how final exam may look like. Because I have another idea of final exam, which may not be necessarily a better one, but maybe we'll have to see, and I can discuss that with you. Does this answer your questions? Okay, nobody says anything. I hope this is okay with you all. So unfortunately, I see there are 2 students that didn't join. I'm only counting you. I'm not sure exactly if the students are not present, or maybe they are just together with some of your friends or their friends in the same computer. So I hope most of you are present. I know it looks like most of you are present here, which basically means that I will continue now with the remaining part of the lecture. What I'm going to plan for this lecture and the lecture after, that is next Tuesday, we are going to continue with a new chapter, a new section. I'll share it with you briefly. Just let me see. Here it is.
Professor?
Yes?
Just to sum it up, I'm sorry to disturb you.
No. Go ahead.
So for the next, how many more sessions we have? 3 or 4? So we have two more lectures?
We have 2 more lectures, and the third one would be the presentation of your projects.
So the quiz will it be during the time of the lectures?
No, the quiz will be outside the lectures. We want to make this as flexible as possible. When you have the chance, one particular day, take the 15 minutes, maybe 30, 45 minutes to solve the quiz. Okay. So you can do it independently at your own convenience. It doesn't. We don't want to utilize the class time.
Okay, perfect. So it will be there will be an email saying when the next quiz will be and everything.
I will send out an email. I will send out. We'll discuss for sure about it next time in the classroom, because the university, as you know, mentioned that there should be no quizzes this week.
Mm-hmm.
We can start them anytime next week, and I think we can do that later in the following week, let's say Wednesday or Thursday, to give you time as well to prepare for it.
So we can assume that the final will be a similar format as the quiz.
Okay, this is what I was saying at the beginning, is that I am considering 2 options that we may have here. And the 2 options are related to the fact that we have all of us, or almost all of us. I'm looking here at this setup here that we have, and I can see that most students, I could say the vast majority of you, already have a camera. So what I would like to see, maybe even a camera and the mic, if we consider that the paper exam would be better. The challenge that we have with the paper exam is the following. After you write your solution, I can send you a file at the time of the exam. At least for now, the university is kind of suggesting, and it's not finally officialized yet, but from what I heard is that we should try to maintain the exam times that we that are scheduled already. Okay, so that means that, remember that some of you, 3 or 4 students, asked me if we can have a makeup exam. And definitely I was agreeable to that, considering the conditions before these restrictions that we live in now. But for now, I think that this will not be possible anymore. And everything is online, and it saves you time from moving back and forth to the university and all this. We should all stick to the schedule of the exam at the same time. This is the exam that would be on the 22nd of April, if I remember correctly. And or 21st. 19 is a Sunday. Tuesday is 21st. Yes, 21st. So that is pretty much would be the choice. And I'm still debating, but I'm asking for your input if you want, on a paper exam where you would work on the sorry, I was looking at the message somebody mentioned here earlier, where you would look at too many tasks that you can do at the same time. I'm sorry. So you would look at a paper exam, as I said, a paper exam that basically says everybody writes the exam at the same time. And then the challenge is how I get this exam. The ability of all of you to scan the exam somehow and send it to me by email, as soon as you finish. That's why having Zoom active during the exam and at the end of the exam would ensure that everybody does this, and not 2 days later. Okay. I'm not sure about WhatsApp. Somebody mentions, what about WhatsApp? Haven't used that, and it's definitely not as secure as we have here, because there is a track record of what's happening through the university servers through Moodle. So I'm not sure exactly what is faster with WhatsApp. Ahmad says that WhatsApp is faster. What do you mean is faster? I don't know if Ahmad is mentioning something now, because I cannot hear you.
Sorry, sir.
Yes.
Would it be possible to have an exam that could last maybe a weekend, and we're able to submit it after, instead of having a time?
So that exam. Kind of open exam.
Yeah.
I guess that's more take-home exam. We've took these kind of exams with the legal issues course. But what I meant by faster for the WhatsApp, by just taking a picture and send it directly. That's I don't know how it's gonna work with Zoom, but yeah.
Zoom also allows to attach files, right? To send files.
True.
Zoom allows to attach files, but you have to generate the file somehow. So use a phone to scan the files, put them in a PDF format, and then transfer it to your computer and send it to Zoom. The attachment only works if you have Windows or Mac. It doesn't work from a tablet or from a phone.
Mm-hmm. I agree with this idea. Actually, it looks more convenient or less stressful, and you can make sure that this is me who wrote this by easily comparing my handwriting with the first or second quiz.
Yes, we are not going to go forensic here.
Oh, yeah.
What I think we want to ensure that you have as less stressful a situation as possible. With Moodle, this is less stressful because it's you, the computer, and the system itself times you up, in the sense of you start the exam now, and if 2 hours later you have to submit, right? Don't have to worry about writing, about erasing, writing back on. You can do this on your paper. All you have to do is type the correct answers in the system. It's not as flexible as with a paper exam, right? But is somehow more uniform. So that's why I would like to see how the quiz works in Moodle. I used quizzes in the past. It's not the first time I used it, but it's convenient when you have a database of formatted problems and adjusting them based on your needs. In this case, we don't really have one. Somebody mentions that if we go by this schedule, some would have, some of you may have 3 exams in less than 24 hours. And unfortunately, this is something that I don't have an answer for yet. Okay. Again, if we go with Moodle, it may be that I can generate different exams at different times for some of you, and still be able to accommodate the few students that have this back-to-back exams in 24 hours. Okay. On paper, it's a little bit more inconvenient. For example, I'm considering the fact that on a paper exam, you really have to have 3 hours or 2 hours, whatever the exam will make. I will make it, probably I'm not making it 3 hours, I'll make it 2 hours to make it less burden for you. But the 2 hours really have to be allocated in an exam environment in which you can focus, you can know how to look for answers, you can know how to write the answers and then submit them, right? If you have, like most of us have a family around you, it would be a little bit more challenging. While if you work on Moodle, you know, having the sound on and off, it doesn't really matter. It's nobody there to look at you, to hear, to speak to. The conditions can be accommodating for this kind of situations. I'm considering this now. Ahmed also raised his hand. Yes, I'm listening.
Hello, doctor.
Yes.
Why not open book exam? What is the problem with that, doctor? I think our course is like a design and analysis. And normally, for example, even in the class exam, as we were told, we will provide all these and all these things.
Open book exams, okay.
Yeah, and for example, for me, if I have open book exam, I may, for example, take a chance, for example, at night to have 1 hour, 30 minutes just to solve one question, tomorrow one question. And, you know, like, because I'm looking for chances to solve that exam, okay, and I can make it within 2-3 days or 1 week, as my colleague said, okay. What is the problem with that? I mean, why?
Well, with an open book,
to make it more complicated than
with an open book exam, it's difficult for me to ensure the integrity all in different packages, right?
The problem is the time. I mean, when we, for example,
I understand. Yeah.
Time, and I'm not actually, for me, I cannot guarantee that time I will be able to solve that exam or to have a chance to solve that exam.
Well, the thing,
unless if that exam will be, for example, 2 o'clock morning, 3 o'clock.
No. Let me put it this way. On Moodle, if I set a quiz to be, because that's how they call it, quiz, right? But it depends on the size of it. It can be a full exam. If I have a quiz that says 3 hours, okay, and you work 1 hour and then you disconnect, and you continue 2 hours later, another hour, and again you disconnect, and another hour later on, that's how it works, okay? As long as the screen is open on the problems, you cannot provide the input faster than that, right?
Yeah, for sure, yeah.
So, and definitely I can restrict that from the moment you start working. Let's say if you set up a 12-hour interval, by the end of the 12-hour interval, everybody should have the answers back. So it's an open book exam, only that is controlled by the system in the sense that it doesn't really allow you easily to move in and out of it. I don't know if I put this right.
I mean, we have to open it, okay, and before closing, we have to fill all these answers. We cannot.
No. It doesn't. It's. I'll show you. In the quiz, is not. Maybe we can do it. You can do it even in the quiz, because I tried it myself a few times, and it says that I previewed the quiz 2-3 minutes, and I closed the Moodle, and then came back later. The timer started from without the 3 minutes that I initially used, right?
Yeah.
So I have only 27 minutes now left instead of 30.
Mm-hmm. That
so through
would be better, I think. Yeah. If we
still an open book exam in the sense of solving the problems. I can even do something even easier. Instead of you typing, for you to provide the solutions in a scanned form, right? To take a picture of the problem and attach it to the problem that is a model. But I want to control this in the sense that having a system that can collect easily all your answers if you want.
Yeah, and sometimes, I mean, what I know about system when grade something or just check the answers, if that answer is 100% accurate, okay, it will be assumed wrong answer.
Exactly.
But manual, for example, when a professor, when a professor marked the exam and during that question our solution has some procedures, and normally this procedure will be considered.
Absolutely. That's why I'm saying that you may even have the type of problem, and some may be some sort of multiple choice where you can easily provide answers. It's kind of a binary thing, but some where you can take a scan of 1 or 2 pages to provide as a solution to the problem, right? So I think Moodle has also this option as a feature in the different types of questions. So everything is adjustable if you want, and we can, we don't have to set it up in stone now. We will finalize it before the end of the let's say second lecture, or before the end of your presentations. So you know, anyway, there is a little bit of time after your presentations. You have 2 more weeks until the exam, so you'd have some time to prepare there.
Thank you.
Okay. Any other questions? Because I think it's been already 3:30 and we haven't started our lectures yet. Okay. If there are no more questions, I'm going to share my PDF file, pretty much the same you will be doing when you do your presentation for the projects. And if you cannot do that, if you know it's not easy for you to share the PowerPoint, all you have to do is to upload the PowerPoint on Moodle. Actually, I think I even have that entry on Moodle to upload the PowerPoint, and I can share it for you, and then you can control the PowerPoint from your side, moving back and forth between the slides to present the file. Even a PDF file is enough. It doesn't have to be PowerPoint, okay? So there is flexibility there. That's not a big issue. Back to what we are saying here is that we have this last chapter, which is on data collection and traffic studies. So just to accelerate a little bit the pace, sorry for interrupting. I'm talking. Find myself these days is not the only meeting that I have online for classes, but all the other university matters. So we are talking a lot and not moving too much. The idea is that we have to look at the needs to collect information about transportation systems in the form of different data setups, and for different purposes. We are looking at system maintenance, system management. You're looking at an inventory of traffic signs, an inventory of signals, of all the transportation infrastructure elements. For different purposes, consider that you have travel time studies. You may have travel behavior studies. You may have, sorry for the noise, information about calibrating transportation models, such as car following models, simulation models, and not in the least information about how you can provide, that is information for decision makers in the sense of validating specific solutions to one proposed or another proposed problem. Consider the fact that we want to deploy or build this new LRT system, the REM in Montreal, right? The light transit system. That has to be done a study before, showing the need and the benefits of such information, right? Of such a transportation system. So there is, there are different ways where we look at this data collection information. How do we collect data? Definitely, the use of modern technology these days has been now evolving very, very rapidly. We have everything ranging from the old systems where you count vehicles with tubes or with loop detectors embedded in the pavement to in remote sensing, infrared detection, RFIDs, wireless detection of tracking cell phone numbers, cell phone devices, and many, many, many others. You can also generate this traffic data in synthetic data, as we call it, in simulation environments, simulated environments, sensors in the softwares, virtual loops, if you want, driving simulators, and so on. So there are a vast array of technologies. I'm just mentioning a few here. Machine vision processors like the otoscope and many others, Maya vision. The idea for these systems, for example, you can see here in this picture, you can set up what we call virtual detectors, and you do an image analysis. You don't necessarily process this information, even these days with the advent of the neural networks and machine learning and deep learning, if you want, all these new buzzwords, if you heard them, you can detect the type of vehicles. Now, this basic detection here is look at the change in the configuration of an image, of a surface area in an image that is moving, and can count vehicles as they move through. See, there are different algorithms to do that. And then you can distinguish the different types of vehicles. You can see vehicles and bicycle. Some issues may occur if you consider that this is another lane here next to it, even though this is not visible in the square here. You can see that this truck is basically encroaching on the next lane. So it would be detected as two vehicles actually when it's only one. But then these are limitations of the detection program, and you can try to make it better and improve the detection with different methods. So you can have other sensors, more sophisticated, laser-based LiDAR. It's based on the light pulses. You can have infrared systems. You can have magnetic systems. You can detect with these. Infrared is sensitive to also to the environment. You can have sun reflection from different surfaces, may change the ability to be accurate, but it also has the identification of the vehicle types. As you can see, this is a bigger footprint of a vehicle versus this one, and you can have vehicle classification, which is important in data collection. Vehicle classification can be done also with magnetic sensors, not necessarily with the same level of accuracy, or if you want the level of discretization. But for example, here is an interesting example of a vehicle with a trailer. You can see the two levels of change in the inductance, if you want, depending on over a certain distance. So depending on how you place the sensors, basically, you can generate a lot of data. And what do we do with this data? This is what we are trying to do in this lecture, trying to see how we can use the data for the purpose of transportation studies. Now I'm going to stop here briefly, just to remembered to mention this to you. Today, we'll try to cover this whole set of slides, if not possible. You have the slides here as well. If you remember, I gave you on Moodle, I provided you with sorry, it's escaping me now. I meant to say a PDF file. Yes, a PDF file that says part 4 PDF. So hopefully you can see that there, and to follow the slides in advance. If you have questions, you can look at them. Sorry. The idea is that today, if we finish this set of problems, this set of new knowledge, then I'll have next lecture as a review lecture, if you want, with all different kinds of problems that we've solved so far and different concepts. I think this would help you, focus on studying specific aspects of this course. If not, we'll finish it next lecture, but for sure I don't need the whole lecture to finish it. I hope that. And if that's the case, then again, we still have some time to provide you with some example problems in preparation for the final exam. And I hope this is helpful. This is what I want to mention from the beginning. So back to the content here. The idea is that we generate pretty much tremendous amount of data these days, and the data comes from explicitly for transportation purposes. Sometimes people try to look at data in the form of from other sources that is related to transportation needs, to transportation models and the applications. Considering this pandemic that we have, if you want, research has already established that air pollution in the most affected countries that started a few months ago, transportation, travel restrictions. They noticed that air pollution in those specific territories really dropped significantly. So this is definitely in line with the general agreement that transportation sector is really providing or impacting the environment significantly. Now that people had to stay put, had to travel, only for for essential needs, they noticed that the air quality significantly improved in those areas. So if you want to see the positive side, if there is one positive side of this generic worldwide problem. So again, data can be generated from different sources, and sometimes we live in an area where the people call it big data, because more than anything, information is very valuable, and all kinds of analyses and problem-solving solutions are generated based on this data. So how we combine this data from different sources, it could be specifically for transportation, it could be data from social media websites that can be, like third-party sources for data, how we filter it, how we correlate the data, and how we use this to generate information for various solutions, for alternative solutions, if you want, for different problems. This is a set of possible studies. This is, if you want, more classical kind of studies, volume studies, if you want. Any transportation agency over time is generating information about what is the travel demand in specific areas of a city or of a province. We're looking at speed studies to identify if there are any safety issues and particular hotspots of a transportation network, travel time studies for transportation demand models, delay studies and density, and so on. There are also some more specialized studies that are required more or less. Doesn't mean that they are not occurring frequently, but they are required for many types of needs and projects. If you're looking at environmental impact studies, these are all requirements for any small transportation project. If you're considering developing a land that hasn't been used except for agricultural purposes or for not developed at all, to build a commercial space, we would have to identify environmental impact assessment for that particular project. Pedestrian studies related to accessibility, mobility. It could be studies that are purely done for the purpose of generating models, such as traffic analysis models, simulators. We discussed about highway capacity manual, how certain guidelines and design methodologies are based on recommendations for HCM, but these recommendations are coming from this evidence that they are doing calibration studies for the purpose of establishing what is the perception reaction time, what should be the value used in certain conditions, such as for intersections, such as highway and so on. Do you have any questions so far? I'm maybe talking a bit too fast, but it's not necessarily something that you may not have been familiar with. Okay, no hand raised. I'm looking here at my screen. I will try to continue. So what we are trying to do in here is to look a little bit at the probability and statistics as they apply to some small set, if you want, of transportation problems. And first of all, we have to definitely be aware that when we collect the data, we have to find out how much data we need. I mean, we can get a lot of data and still not getting the data we need. But based on the data we need, we'll find out how much data we should collect. That is the data that is going to be representative, and this is one of the important aspects of the statistics, right? What is the representative sample? What kind of data we have to figure out that we are collecting the data resolution, considering that if you want for data resolution, the example that I have is related to the type of sensors that we have in the field. Oftentimes, our sensors are able to detect vehicle presence on a regular basis, individual vehicles, but then the data is going to be aggregated, averaged. In other words, you make averages every 2 minutes or every 30 seconds or every 5 minutes. So level of resolution for this data will be suitable for specific applications. Obviously, the higher the resolution, the more frequent the data is collected. That's what it means. The more applications that rely on high resolution are suitable. And the methods we apply for this data processing is very important now to have confidence in our results. Okay, Ahmad raised his hand. I'm listening. Yeah, Ahmad, you have to unmute your mic.
Yeah, sorry. Okay. I was wondering how far we can go with the methodologies that can really and depend on decision-making conclusions. How far critical these can decision be made, and so on. Like I just can't imagine depending on a specific algorithm, and based on a certain approach, we can really depend on making a decision.
Yeah. Okay, this is really thank you. This is specific to the type of application we have. If you consider that you are, let's say, collecting data to identify the usage of non-motorized transportation in the city. That is everything that doesn't have an engine, not an electric motor like the scooters or e-bikes, right? So non-motorized in the sense that mostly talking about these means of transportation. The methodologies really depend on we are using. Depends on what you're trying to achieve there. Do you want to detect if you are considering the usage of a transportation system, let's say using bikes in particular, for specific purpose? Is it for recreational purposes or more specific for commuting purposes, right? Because basically that's what we consider. People going to work or going to school using one of these transportation modes that's sometimes referred to as active transportation, versus using it just for the purpose of recreational needs, enjoying time with friends and so on. So one purpose of the transportation or another would still require a specific amount of data to collect. Then you want to identify maybe the impact of the age of the population. Find out the probability that some of the representatives from the elder population would use this, and if the purpose is to make it more accessible to them, you would have to find out with additional information rather just using the data itself, just maybe making surveys, identifying what are the possible additional features that a transportation system like that would be considered to bring higher ridership in a certain age group, right? So making the bikes easier to unlock and lock into the docking station, maybe making the bikes more visible to improve safety. Imagine that you're talking about elder population and their reaction time, paying attention to all the distractions on the road and all these. So really depends on the type of study, which the kind of methodology you can go. It's flexible to that extent. Definitely, it has to be validated, and the way we can validate it is basically first trying to see if there are any similar studies. No, practice makes perfect, as they say it. So you try to find any similar studies. If not, at least try to find studies that are not similar in the same context, but in the same purpose. So using different statistical tools to find out significance and reliability of your conclusions. And we'll talk about specifically what it means, confidence of your results and statistical significance. That's what we, in particular, to transportation studies. These are going to be our problems mainly to solve. Does this answer the question? I hope. Okay, good, thank you. So if I'm looking at time, we may have another few minutes, and then maybe we can take a break, or me at least. And in the meantime, during the break, since I not to forget, try to think about any other questions that you may have. We can discuss them after that, or maybe later on. Okay, so in terms of statistical significance, as I said, we want to identify sample size. We want to identify what kind of confidence you have in the results, the confidence bounds, the distribution that is applicable to our study, and see what statistical tools we have available for that. And maybe sometimes we can look at this is an often time section, not just sometime, often time application that is before and after scenario. In other words, these studies often come as a necessity of solving a problem. We react to a problem rather than anticipate the problem. This is not necessarily the best, but oftentimes we don't have resources for various reasons. So think about the recent event that happened on the highway during a very strong and strange snowstorm a few months ago, or actually not, I don't think that more, less than 2 months, I believe, on South Shore. South Shore on the Highway 15, there was a lot of. It's usually a typical very windy system in that area, and it was a snowy day with strong winds that reduced significantly visibility. So the consequence was a pileup of 100 plus vehicles, if I remember correctly, with very severely injured people. So the conditions were such that under this kind of adverse weather conditions, people adjust, and it's enough one person to lose control, and everybody, because of low visibility, will smash into them. Now, what is this got to do with the statistical analysis? Now, think about how would you prevent this to happen in the future, right? Instead of, we have to wait for something to happen before we figure out that we should not allow it to happen or try to prevent it. So one way to prevent it definitely is to inform people about it. But in one sense, you can inform them about it, but another one also you want to maybe increase alertness, include restrictions, and you can do an analysis of the behavior of driving before these restrictions, before this information is available, and after, right? And see if the mitigation measures that you are taking, reducing speed or providing speed bumps, for example, in a residential neighborhood. If you remember, to slow down drivers that go too fast in a neighborhood would be just one tool, and you have to identify, before you put that into the function there, and after we want to collect data before and after and see if the tool is effective, if there is indeed a reduction in speed, there is indeed a reduction in people being more attentive, changing lanes less frequently, just because they are in an area that potentially can have very hazardous consequences if they don't pay attention. So we want to use this data and make some decisions, as it says here, rational decisions, and also ensure that these decisions are effective. Okay, so I think if I take a break now would be for the better, because we are continuing with a new section, which would be on some examples on how we are looking at the basic principles of statistic analysis and what should we consider for the rest, different types of problems. Do you have any questions before we take a break? Okay, so let's take a break until, let's say, 3:10. Not 3, that is 4:10. 4:10, 10, 15 minutes, no more than that, just for me to uh, drink more water, and maybe for you to have a snack if you want. Now, that's something that you didn't do easily in the classroom, so now it is the convenience of being at home. Okay, so I'll see you shortly. Okay, thank you.
Mute yourself.
Oh, okay.
看我的摄像头价格好高，这根线一直连到了电脑上。今天上网课，我的摄像头，学生24个人，现在是课间休息，暂停了，马上就要开始上课了，加油！我的摄像头，学生24个人，现在是课间休息，暂停了，马上就要开始上课了。加油！今天上网课，我的摄像头，学生24个人，现在是课间休息，暂停了，马上就要开始上课了。今天上网课。
Hello guys, I just want to make sure that the system is not lagging. If anyone can hear me, just say hi.
Hi. One hi is enough, or you need more than one?
Hello, everybody. Okay.
Look,
I have a question, Professor.
Yes.
About why do we need to know the type of the vehicle on a signal? Since like with the sensor that we're using on a signal, just like to know and control the cycle length. Like in a signal, it doesn't really matter if it's a car or it's a truck or it's a bus, or it does matter.
There are many. I understand. Is that all?
I'm pretty sure that we really need to know the type of the vehicle on a highway. That totally makes sense. But on a signal, do we really need to know the type of the vehicle?
Depends on the application. Definitely. Think about considering assessing the capacity of an approach at an intersection. We really consider that the capacity is based on, if you remember, I try to briefly make a small notation here. If you consider that the capacity of an intersection is based on the this parameter, let me change the color briefly. This parameter, which is the saturation flow rate. The saturation flow rate comes from the inverse of the saturation headway.
Yes.
But we said that this depends on the vehicle type, if you remember, because if you follow two trucks, they have a bigger headway versus two small cars.
That makes sense. Yeah.
So now at the intersection, what is important on that particular arterial, see the percentage of trucks, and definitely the remaining would be the passenger cars, right?
Yeah.
And then you can find out an average saturation headway. Maybe this is what I meant to say, average saturation headway. But that's one application that you can consider.
Totally makes sense. And the other question, why we mean exactly by the sample size is the vehicle size, right? And that's like particular slide number 13.
No,
this is what
the sample size. The sample size
of the
basically
data.
Number of observations.
how many data points do we need for that?
Number of observations. Consider the fact that we are looking at 1 hour of data that we collect for vehicles approaching an intersection, right? this hour today is one number, tomorrow is another number, the day after tomorrow is another number. The true value will difficult to know, right? So think about if I can make a parallel here, somebody is targeting uh, um, um, a shooting range, right? So what you have is somebody you get here, sometimes you get here, sometimes you get here, but it's difficult to always get in the middle. And this is called the ground true value, right? So in order to get value, to get the true value, basically you try to look at it a few times and get an estimate by calculating an average. So now the average comes from these observations, from this sample. You are not going to go there for every day for the next 3 months to get an average. But if you do it for 2, 3 days, 5 days, 10 days, under the right conditions, when you do analyze this data, you would have some confidence that the statistics you get out of it represents the population, represents the true value.
The actual status. Okay, that's clear. Thank you very much, Professor.
And we'll have some examples shortly.
Yeah, thank you.
Good. Okay, so looking at the next slide here, we have some measures of the data we are collecting. And important here, definitely you can consider that you want an order here, 1, 2, 3, 4, 5, and so on. It's not necessarily the case that one is more important than the other. It depends on the application. But oftentimes people look at an average. Okay, average in the sense of what we call weighted average. Everybody sees my annotations on the screen, I hope. If not, let me know. So we look at mean, we look at the variance, we look at the standard deviation, which is the square root of the variance. But remember that these are representative for the sample, typically for the data you collect, not for the population. Again, if you want to refer to this tragic event that's happening these days, we are living history right now. You can say, 1.5% of the population that was in Italy, I think, 1.5% of the population, I was looking at it a few days ago, was affected, right? They were cases of people that had the virus. Only 1.5%. And then again, 1.5% of those that had the virus, unfortunately, died, right? But this is just a sample, because you look at the population of Italy and you look at the proportion of people that got the virus, it's going to be another reference for another country, right? It's not the population of the world, it's depending on these conditions. So simply isolating just one measure, one parameter, which is the number of people versus some other conditions, may not necessarily be enough. A very small country with or the same number of cases, if you want. Now Italy is getting close to the total number of cases China had, official numbers. But imagine now that China has a population that is 40 times, if I'm not mistaken, or 400 times bigger, right? So it's you have to take all these numbers, all these statistics, oftentimes with what they call how they call it, I don't know, a grain of salt. You have to be skeptical in how the results are presented and what they represent. In other words, how they sample the data, how they analyze the data, and then is this data representative for the whole population or only just for that, or the analysis representative for the population or only for the for the sample. Another important, sometimes variable, definitely, this is the standard deviation, which is used to identify confidence intervals. In other words, what is the probability that your conclusions, are valid? Okay, so in which range the conclusions are valid. Median is the 50th percentile. If you remember, if you do a cumulative distribution function, what we have for the median, basically it says, let's say this is the velocity that we observe on the road. We consider that this is, let me write this a little bit better. This is what we see here. If this is 1 or 100% and this is 0, you can say that this particular speed, this is velocity, is 0.5, right? In other words, 50% of the drivers would have a speed which is this value, let's say V naught, or less. 50% of the drivers will have V naught or less than V naught. And then the other 50% would have V naught or greater than V naught, right? So what is this V naught? Remember, for our traffic engineering traffic signals, when we looked at the velocity for the dilemma zone, we said that we want to consider the IT traffic handbook says you should use the 85th percentile velocity for the vehicles to go through the intersection, the speed to proceed, and the 50th percentile for the vehicles that are stopping, right? So basically, they are considering that you can get the percentile speed like this from all the data you are collecting, and consider the conservative case, right? To cover the high-speed drivers and the lower moving drivers in both conditions. Mode, I don't know if you used it earlier in any application in your previous courses, but if you consider that you are looking at the frequency of data that you are collecting, let's say you are collecting data like this, I don't know what it may represent, but you split the data in different categories. Let's say this is step velocity, 10 miles per hour, or 10 kilometers per hour, 20 kilometers per hour. And then here is 90 kilometers per hour, let's say the velocity on a small street. Let's say most of it, 30% of it is the highest frequency is in this range of 40 to 50. Let's say this is 50 kilometers per hour. So this is the mode, value with the highest frequency. For different distributions, it may be close to the median. Sometimes it can be close to the mean. It depends on the type of data they have there. Then the percentile values and the range, that is the max between the difference between the max and the mean values. Andres has a question. Sorry, I just noticed it.
Yes, sir. Why did they decide to use the 85 percentile instead of, let's say, 90?
Definitely, I cannot have a definite answer here, but my common sense here basically says you may want to look into the studies, the NCHRP studies that are at the base of the IT recommendations, show that practically the 15th percentile has the range of speeds, I'm thinking, the range of speeds that are unreasonably high, right? Because what we are looking at is trying to accommodate for this distribution of the speed, also the ability of the drivers to maintain the regulation, right? So if the velocity, the speed limit there says 70 kilometers per hour, you may encounter a high number of drivers that are not respecting the value, right? but still, you cannot really say 50% of the drivers are going with 70 because that's what you see, and the other 50% will not be accommodated in the sense that that's where the value is, right? So you go with a little bit higher than the median. You put aside the 15%, and at the other extreme, you take the 15% that are very slow drivers, right? So 15 and 20, 85 could be easily done. We have to look at that particular report. There are more reports than one probably that were conducted. So there are studies, especially as I mentioned at the beginning, calibration studies. They have been conducted studies in different configurations to see what is the trend, what is the behavior. So they came up with this 15 and 80 percentile. Now, remember, this is the recommendation from ITE. It may be that in particular circumstances, one particular agency may say, I don't want to go with 80 percentile because what I see is very high speeds for 85th percentile. So I can even lower it. And I don't want to accommodate very high speeds because it creates a big gap between the drivers that are there and not going with that speed, and drivers that most of the drivers that are not going with that speed, and then other drivers that will go. So we can even lower that if you consider that the percentile. This is one possible one part of the decision making. Okay. The percentile, but the actual speed is also important to validate, because considering on a 70 kilometer per hour speed that you want to go with accommodating drivers that go at 90, then you are encouraging a lot of behavior that is unsafe.
Okay, thanks.
So yeah, it really depends on the application, and that's a very good point. So next, how do we use these distribution measures? I'm sure you took some basic probability statistic courses. I'm not going to go into many details. It's more of a refreshing of your previous knowledge. Basically, we are looking at different average values. This is the average speed of one particular transportation mode. This is the average speed of another particular transportation mode. Then you can do a weighted average depending on the number of observations, if you want. Also, you have to estimate the variance, right? The variance and the standard deviation based on the same principle. Now, here is an example that is looking at different transportation modes for a trip that has three steps, three components. It says, sorry. One is the person maybe is driving the vehicle from the residence to a parking lot near a commuter rail, takes the train to a destination, and then the destination changes the mode to a bus to get to the final destination, right? So here is an information about average travel time for this particular person. 7 minutes with a standard deviation of 2 minutes, 45 minutes with standard deviation of 6 minutes, 15 minutes with standard deviation of 3 minutes. So these are maybe different recorded trips of the same person doing this trip in average with these values. So what would be the total trip time based on this information? You are considering just one person, so we are looking at one person that traveled 7 minutes, 45 and 15, so in total of 67 trip lengths, multiple sources of the same observation, right? Different averages can give you a different value here. So the average for a group of 100 people, let's say, and similarly, you can estimate the variance. Now, the variance is important because the square root of the variance represents the standard deviation. And standard deviation is used depending on the distribution in different formulas, but the idea is the same. The standard deviation gives you a confidence of a trip occurring with a certain travel time. Okay, so when we make decisions in the sense of, I'm choosing to live at a particular location outside the city, traveling to my workplace and back. I consider a certain average travel time, let's say about 40 minutes, but it's not always 40 minutes. Sometimes it's plus or minus 5, 10 minutes. I don't know, depends on the conditions and all the other factors. So this can be used in your transportation planning models where such information would lead to a certain distribution of the trips in the network. Now, any questions? Let's look at the second example. Sorry. So the second example is about our 100 units in a condo, right? So there are 100 apartments in a condo building, and there are many such observations for many condos. What they observe is that the average number of parking spaces, it's shown here, average number of parking spaces that is desired for this system of 100 units, it's 70. So we have 100 apartments and then 70 parking spaces in average, right? This is an average. Remember, we are looking at the mean value. And also there is information about the standard deviation. Since you have so many observations there, you can get the standard deviation. Now we have to use this information for the next for a similar problem, but with a different context. Instead of 100 units, we have 1,000 units. So you are changing here the input. But in order for you to do this, basically you have to assume that there is some correlation between this need of number of parking spaces and this input variable, the number of units in a condo, right? So kind of assuming that they are proportional, more units, the more parking spaces. But is this a direct proportional, a linear relationship, a non-linear relationship? Basically, this has to be proven somehow. So in this basic example, we are considering that this is a linear relationship. So 1,000 units, basically 10 times more units in a condo, basically this would lead to 10 times more parking spaces necessary for this structure. So if you are to apply the numbers that we had earlier, the formulas that we had earlier for calculating the average and calculating the standard deviation and the variance, in this very example, we have this average basically that says I'm looking at 10 times more condos, 10 times more parking spaces, and in terms of the variance, we have 10 times larger standard deviation. Instead of 4.6, we have 46, right? So the same proportionality. This is definitely something that we would assume. On the other hand, if you want to be more accurate, you would probably try to get a little bit more information in terms of additional data that could provide you more reliable estimation of the parking spaces in this case, not simply relying on the past in historical data of something similar, but maybe identifying what would be the average, average income of the condo owners. What is the household structure in terms of demographics and socioeconomic characteristics. So maybe more information would give you a more reliable model that's just simply using the proportionality between the number of condos and the parking spaces, right? So that is to say, somebody asked earlier a question about the methodologies you're using. Really, the methodologies are highly dependent on the available data and identifying the needs for specific levels of accuracy would practically drive the data collection, right? So in terms of statistics, there will be a little bit more that we will discuss, but I mentioned about probability earlier, and I think maybe just a quick refresher on the probability. I remember we had a test at the beginning of the semester and asked you to review these concepts, and I hope some of you, if not all of you at least, some of you tried to go back and identifying what is a random variable, right? So stochasticity or randomness is really the salt and pepper of our life, if you want, not just the transportation system. It's good to have it. It's at the same time is not something that we would easily model it. There are many attempts and different methods and different levels of acceptance of how you can model randomness, but basically the most common concept here is about probability. So we are looking at what is the likelihood of something to happen, and now what do you do with that likelihood is really another step. It's an outcome, right? So we are talking about different outcomes. You're considering flipping a coin. That's a binary outcome, right? It's going to be either head or tail. The probability here is very straightforward, right? For flipping a coin is 50-50. It's a very random process. The repeated event of a binary distribution or a binary random event is what we call a Bernoulli distribution or a Bernoulli experiment. So a binomial, sorry. So it says, oops, I'm sorry, I just lost my tool here. It says, yes, the binary outcome is a Bernoulli distribution. And this is straightforward. I hope you remember this. But also the fact that if we repeat these Bernoulli binary outcomes in a certain number of times, we get what we call a binomial distribution. So binomial distribution in this case basically is repeating this event a certain number of times, this n times, right? So here is a little bit more complex probability. Definitely the probability that an event occurs with a certain value depends on the number of repetitions, right? So you have a formula for identifying what is the average outcome, basically the average of that event happening. Flip the coin 10 times, or maybe this is quite straightforward. Think about rolling a dice that has 6 sides 10 times and 20 times. What is the probability of observing one particular outcome? Now, similarly, you can calculate the variance, and obviously the standard deviation, the square root of the variance is the standard deviation, right? Sigma is the square root of the variance. Now, anybody remembers why there is a normal distribution? What does it mean, normal? Nobody wants to. I'm inviting for questions now. Normal distribution basically is defined as such because it seems to have been observed in normal natural processes, right? And what is more important here is that if we look at flipping a coin um, multiple times, or maybe since it has more than two outcomes, rolling the dice multiple times. When you look at the average of the dice having one side, which is 1, and then another side which is 2, and another side which is 3, and so on, you would have different probability values. Definitely, if the dice is perfectly square, maybe over a very, very high number of rolls, you'd have the same probability, even probability across all sides. On the other hand, if you're taking the average of all these averages, this average would follow a distribution which is called the normal distribution. And I'm going to skip to the next and then come back to this slide. There is a theorem, and that has been proven practically, and we are going to use it, which says that the sum of n similarly distributed random variables, okay, so we have random variables that are all coming from the same distribution, will approach the normal distribution, regardless of what is this random variable's initial distribution. So if we're looking at, let's say, the headway, the distribution of the headways for vehicles, if you're looking at measuring these headways, let's say, with different types of vehicles, only passenger cars and then only trucks, and any percentage of trucks and passenger cars in between. If you look at the average of these headways across all the combinations of trucks and passenger cars, all ranging between 0 to 100%, and then this one's obviously 100% to 0 in contrast, right? Because the total should be also 100, always 100. The average of these headways, the average of the averages, if you want, the average of all these averages would follow a normal distribution. And this is very interesting because for normal distribution, we have very straightforward and easy to measure some performances, and that most important one is the confidence interval. And practically, this is what we are looking at when we have this previous slide that shows how the standard deviation here is used to identify. Remember, this is what we call the probability distribution function, PDF. The probability distribution function, basically, in this case, says that 68%, this first, for the normal distribution, 68% of the averages fall within this range, which is take an average, and then you subtract either sigma or you add sigma. So this is mu plus sigma, and this is mu minus sigma, right? So if you're looking at these two, basically the range between, it is called confidence interval, between mu minus sigma and mu plus sigma, 68% of the time you would be in this range. Now, if you want to be more confident, you can use 95%, and this is most of the studies that look at 95% confidence when they say what is the likelihood that you will observe a certain travel time within a certain time interval. It's 40 minutes plus or minus 3 or 5 or 10, whatever it is that is sigma or 2 sigma it is there, right? So it's almost 2 sigma, 196 sigma, that gives you 95% confidence. 95%.5 is 2 sigma exactly, and then 99% is 3 sigma. That's a very broad range. So the idea is that if you need a specific accuracy of your estimate of your average here, you would best try to get your sample as high as possible. It's not necessary that it has to be high, but it has to be representative. So identifying how large this sample size has to be really depends on the type of the initial distribution. But the idea is that any distribution, if you do the averages of the variables from the same distribution, and you try to get the average of these averages, then they all follow a normal distribution. And this is convenient because for the given distribution, you can calculate sigma, and you can calculate easily the standard, the confidence interval. Do you have any questions? Not so far. Good. So let's look at another distribution, which is.
I have a question, sorry.
Yes, yes. I'm listening.
I can't hear it correctly, so. Okay, I don't know. There's something happening. Okay.
I can hear you. I don't know if anybody else can hear you, but I can hear you.
Yeah, we can hear you. Yeah.
Ahmed?
Okay.
Ahmad, can you hear us? What is the question?
Hello, Ahmed, are you there?
Not quite.
Better to write your question.
Voice went completely off.
Right,
Okay.
right, Ahmed, if you hear us.
Okay, he cannot hear us. Okay. Maybe this is for everybody. If you, yes? You can connect from your phone if you want to talk to have a better connection, audio connection. Okay, Ahmad, we can hear you now.
Yeah, it got back. I can hear it. Sorry for.
Okay.
I don't know what happened, but thank you.
So you can hear it. Okay, so it was an audio issue, right? Let me continue. Yes. So remember Poisson distribution? Poisson distribution, I used it for modeling the headways, inter-arrival times. And we said that a Poisson distribution basically has the advantage that its average equals its variance, right? You can see here that the average is m and the variance is also m. So that's one of the characteristics of the Poisson distribution. But practically, binomial distribution becomes a Poisson distribution when the remember the formula for the binomial distribution that showed here what is the standard deviation and what is the variance, not the standard deviation. So practically, if the two are square root of it is the this is the variance. That's right. So practically, binomial distribution back here shows that your binomial is a Poisson distribution only if the probability of occurrence of the event there is very, very small. In other words, 1 minus p equals 1, right? From here, basically, you are saying that this is equal to 1. It's approximately 1. In other words, p is very small, right? So the probability of the event occurring, the binomial event, is very small, and that this distribution becomes Poisson. So there are so many different ways to look at these variables, random variables, stochastic variables that come from different distributions. Once you can estimate their averages, and you can average over these averages, and I'll show you where we use this in transportation very frequently, is, sorry, you stopped seeing, I guess, my slides, or not?
No, we still see it.
You can still see it, but you don't see it refreshing. So just a second.
Yeah, maybe. We can see you now.
Give me a second. Running out of power. Okay. So my screen doesn't cooperate with me. But it will take another second for me to find out. Yes, it should work now. Okay, now it works. I surely hope so. So I hope everybody can see this. This is, remember we talked about the regression analysis as a solution to find a better estimation of the parking spots available for a different setup condo. Well, remember that we talked about regression, and again we have some methods to conduct it, automatic tools, now different software packages perform the regression for you directly. The idea is that we need to make a good interpretation of those variables, right? So we are looking at just want to make sure everybody can see, not necessarily myself, but just to see who is what is showing here. Okay, it's okay. remember that the goodness of fit of a model, in other words, the ability of the regression to represent the data correctly, it's given by this performance measure, which is called coefficient of determination. Oftentimes, people just call it, how do they call it? They call it R squared, right? It's R squared. This is, remember that this is coefficient of determination, and it's basically showing how much of the variation square, I meant to write here, how much of the variation in the model is explained by the variables. And overall, right, this is the generic model. Let's say this is 90% of the variation is explained, of the total variation, and some variation is not explained, right? So if this is the regression line, that should be ideally, these are the points I'm looking at. Some are here, some are on the line, some are under the line, some are above the line, and the average line here is this. Some is explained variation, some is not explained, right? It's not explained by these variables. It means that we have that additional sorry, my mouse is not working. Now it's working. Some of this variation is embedded in the constant of the regression model, right? So we are looking at some estimators. Basically, this regression is for the sampled data, but for the population, we assume that we have represent as an estimator. We have assumed that we estimate the average population, the true value, with the average of the sample, right? So this is what we are going to consider for the average value, assuming that the variable is coming from a normal distribution. And we said that any variable can be modeled with the normal distribution as long as we apply the central limit theorem. And that's, I remember what I wanted to tell you, is that consider that you have your simulation models. Some of you try to use simulation for the project. Well, the simulation model has, in particular, some variables that will change, and may take a little bit of time here to explain this. But remember that vehicles are modeled in the network at different headways, right? And if you run the simulation once, you would see these vehicles following each other with different headways. If you run it another time, you may see that they really change the positions. They are not following the same headways, if you want. So this is one simulation, this is the second simulation, and so on. Let's say we do 30 simulations. However, when we look at the average headway here, and the average headway here, and the average headway here, and that's 30, all these headways, we'll see that they are not changing much, these averages, and moreover, these averages come from the same distribution because they represent the same variable, the headway, right? Now, why are they different? It's simply because when vehicles are released into the network, when they enter into the network, there is what we call a random number generator basically decides, a sequence of random numbers, and you can think now of a sequence of random numbers, 1, 7, 23, and so on. The idea is that this ends up somewhere here, and then it repeats itself. It goes again, 1, 3, 7, and so on, right? Now, if we take another simulation, it would be another set of random numbers, 2, 5, 23, 10, and so on. It repeats n1, n2, and again 2, 5, it repeats, right? So it's a big chain of numbers that are randomly generated, and they are used by this simulator to find out how your vehicles are released into the network. However, since we are using these numbers pretty much, if you look at them It's just we are changing the orders, but use the same sequence. So we use the same. It's a uniform distribution here of all these numbers, natural numbers between 1 and 1,000, if you want. But if you pick 100 numbers at random and you shuffle their order, you would have shuffling the order of the vehicles this way and the shuffle the order of the headways. However, the vehicles, the headways of these vehicles come from the same distribution every time. So when you do this average and do this average and you do this average and you do an average over all of them, right, sum them all up and divide by 30, you would get this variable, this new variable, which is following a normal distribution. So for this normal distribution, normally distributed, if you want normal distribution variable, you can apply the confidence limits, if you want, by calculating the standard deviation and say 95% of the time this headway is probably, I don't know, let's say 2 seconds plus or minus um, 0.5, right? Let's say I'm just came up with some numbers. It doesn't really mean these are the actual numbers. But the idea is that you can estimate this um, confidence limits for a parameter, which is a stochastic variable, the headway, as long as you do a sufficient number of these of all these simulations. All these simulations have to be modeled. So at the end, applying the central limit theorem, the normal distribution of the means is valid. And what we have to find out is, if this number of samples, number of simulations, 30 simulations, 10 simulations, whatever it is, are representative for the population, right? And the estimation of the standard error, which instead of considering that we have standard deviation, what we call now is this is a standard error, right? So the standard error basically um, is given from the standard deviation of the sample divided by the square root of the number of observations in the sample, number of observations, yes. So number of samples, if you want. So we are kind of using now our sample, which is, this is what we have here, a sample. Let me erase all this. We have a sample here, and the estimating the variance of the sample, we assume this is the variance of the population. Estimating the average value of all these means, we assume is the true mean of the population, right? So really, in all the studies that you're making, you are not referring to the population anymore, but you have to be aware that identifying the number of samples to represent this population is very important to get it statistically right. So some applications where we use this estimation of the variables, it's hypothesis testing. Any questions so far? Nobody raising hands or sending messages? I hope not. I'm checking here. Good. So this is what we were looking at. I said hypothesis testing. So we can let's say assume that the headway of a particular the average headway of a particular population sample value, let's say before we put there some traffic calming measures, reducing speed, informing about radar enforcement and so on, we can estimate if vehicles are really traveling at instead of speed, instead of headways, let's use speed, because speed is easier to compare in this case, right? So what we have is the idea that before we put some traffic calming measures, we have some average speed, which is S1. After we put some traffic calming measures, as you said, speed bumps or traffic cameras, we have another average speed. So we have two average speeds. These are velocities, and we want to compare if they are the same or not. Now, normally when you look, if they come, in other words, statistically they are the same or they are different. So that's the only thing that you can say, if they are the same or if they are different with this hypothesis testing. So in other words, you can say S1 minus S2 may be different from zero. This is the hypothesis we are testing. This is H naught, the null hypothesis. So we can identify that this is true, or we can, and indeed from our sample, this may be true, and it may be representative for the population. It may be that this is they are not equal to zero, they are indeed equal to zero, and again the population may be equal. So this is correct output, if you want, this one and this one. What is uh, the uh, the truth and what is the test that is doing if you look at the sample. But you may have the erroneous conclusion that the null hypothesis is false. We reject it. In other words, if they are equal, we can say here S1 equals S2, but in reality they are different. This is type 1 error. And fail to reject the null hypothesis. This is even worse, if you want. That is S1 not equal to S2, but in reality they are equal.
Hypothesis.
So the hypothesis testing, when it comes with this confidence bounds, when it says 95% confidence, basically it's telling you that the hypothesis testing, the output of the tested data is 95% of the time correct. And then we accept, let's say, in most cases, 5% to be wrong on our outcome. If you need more confidence, you can go with 95.7%, you can go with 99%. Just make sure that no, there will be no, depending on the application and transportation studies, we don't really need high confidence, but in other fields, let's say the fail-safe systems of rocket, or airplane systems, you want to make sure they will never fail, right? Sorry, the number is relatively rare to assume, as you all know, but at least for a very long period of time, you assume that these systems are really providing, reliable service, whatever the service is. So if we consider our problem back here, here is an example, if you want, a very straightforward example. Travel time on a given route is known to be 60 minutes, and the experience has shown that standard deviation to be about 8 minutes. An improvement is recommended that is expected to reduce the true travel time to true mean travel time to 55 minutes, right? So here is a way where we can really apply the central limit theorem, and if you want the hypothesis testing, because we know that before we have this information, the travel time being 60 minutes, and after whatever improvement we chose, maybe high speed reserved lane for drivers, we facilitated, made bigger shoulders to facilitate easy bypassing without probability of accidents happening, whatever methods we had. Here is the expected travel time to be improved to 55 minutes, right? So we really don't care much about these travel times. That is, as you don't need to know the travel time, the distribution as a variable. Looks at all the vehicles traveling there. It's still the same variable before and after. So you expect that they come from the same distribution. So anyway, when I look at the average travel times of all these values, they are bound to approach the normal distribution according to the central limit theorem. In other words, we can apply this hypothesis testing where the okay, sorry for the crooked image here. On one hand, we have the average, and the other hand, we also have the standard deviation, right? The information was on. Sorry, I have data here. Standard deviation 8 minutes, right? So we look at an 8-minute standard deviation if we consider that the difference between the two, you see, the difference between the two is only 5 minutes in this case, right? So maybe if you want, what we would consider here, I would put here a new screen, but maybe I can draw it on top of this. Here it is. Our maybe a little bit further apart. This is our 55 distribution. So if I take this distribution here and I place it here, basically I get something like that, right? Now, this is what happens. Depends on the standard deviation and the fact that we are looking at either 95% or 97%, whatever it is. We would consider that the hypothesis testing is that the two different values are equal, right? So if, let's say, I'm looking at 95% confidence range here and 95% confidence here, as long as this upper bound here is less than the lower bound, right? If this value is still something that we can account for, they are not overlapping, then hypothesis testing shows that confirms the null hypothesis, if you want, that the two travel times are equal, right? The two travel times are different. So we do have that null hypothesis here.
Travel time.
Sorry. The null hypothesis is that mu1 is different from mu2. Or maybe, how did we draw it here?
Alternative. Now reject alternative, reject alternative, or fail to reject now. Fail to reject now.
That's right. In other words, if we look at our data, this is before, and this is after. I hope you see it now. What we can say is that we are looking at a particular experiment, right, which identifies after our improvements that the headways here, mu, are within a certain range of I would say, let's say, put here 57, and this is plus or minus 53, right? So I'm assuming here that our 1.96 times sigma is about 2, right? 55 plus 2, 57, 55 minus 2, 53. So at 95% confidence, I know that the upper bound here is 57, while the lower bound for the
Upper bound.
before average is 55.7. So they do not overlap. In other words, there is no probability, 95% confidence. It's not 100% confidence. But with 95% confidence, I can say that the average here is in a range that is different than this range. In other words, I confirm the null hypothesis that the two are different, right?
The two are different.
So if that's the case, then
with 95% confidence, we confirm that these two are different.
Have a conclusion. I fail to reject the null hypothesis.
I fail to reject the
but the
null
problem
hypothesis.
is that your confidence really is
percent confidence.
In statistical analysis, what we always want in terms of the assessment, because that's what we can do, is to reject H null, the null hypothesis. Because that's what we can do. We always reject null hypothesis with this confidence. In other words, the way I put the null hypothesis here, sorry, I didn't know that. Let me see, I can put it back. Whew. I thought we missed it. Is that these two are equal. So if this is my null hypothesis means mu1 equals mu2. In other words, before and after, there is no change. I know one says 55, the other one says 60. But remember, these are average values. And they range in a specific, they change, take values in a specific interval, right?
Interval.
Range in a specific
interval. Value in this
so while they are indeed different,
interval,
since they represent averages, statistically, they may be different, or they may not be different. My assumption here is that the way I noted here in this range is that they are different. That's why I say after the studies, even though I say this is 50, the assumption is that this is 60, right? So sorry, what is this? I didn't mean to put it on top here because that's not clear. Back to this slide. If the null hypothesis, the way I put it here, is exactly this, this is the null hypothesis. The two values are equal. If looking at the data, shows this, exactly this. So the data basically means I'm going in the field, measure the velocities before and after, and if I plot the confidence intervals for these velocities, because I have many samples, I can get the standard deviation. 195 times standard deviation plus or minus gives me the confidence interval. And I have exactly these values that I see on the board here on the screen. Then basically I reject what my null hypothesis is. I reject my null hypothesis. In other words, I'm saying that these two are not equal, before and after. In other words, I have the conclusion is because everything is done for the purpose of doing an assessment of my method. It says that to improve the travel time, the method to improve travel time. So I'm concluding that the method indeed has some positive impact. So it's not enough that I look at the two averages. This is what the main conclusion that we take from here. Not that I'm looking just at the two averages, oh, they are different, it means that I make an impact. It doesn't mean that they are different, I make an impact. If they are different and the distributions are such that you can reject a null hypothesis like this, it means that 95% of the cases, that I have confidence that they are indeed different. So I don't know if you want to take a screenshot of all these, but because it doesn't say in so many words, these two graphs, what I'm looking at. I'll improve maybe a little bit the slide here to show a little bit less crooked images and some details that I can put on the screen as well as in these annotations.
Annotations as well.
So when we test the null hypothesis exactly as what I mentioned earlier is shown here in the full words. Remember, we have to look at the standard deviations for the
we have to
before
look
observation,
at
standard deviation before after the observation.
deviation.
They represent the variance, right? If we take square root
before,
of the variance over n, gives me an estimate of the standard deviation, right? Which is denoted by s, which is sigma divided by square root of n.
Travel time.
Remember, we are looking at samples versus population.
Samples versus
I think
population.
there is another example here. Do we have any questions so far? Ahmad, yes, I'm listening.
Yes, can we go back to that slide that we have two graphs? I kind of, yeah, with the curves. I think it's 35.
This one.
35.
Oh. This.
Yes, exactly. So although here we're saying that the travel time is actually different, but overall it's not, we don't have any impact. Is this like the conclusion that we got? Overall, we're reducing the travel time. Can you hear me?
Yes, just a second.
Okay, yeah.
This disappeared, I guess.
Yeah, I'm saying, like, although the travel time is changing, and looking at the mu1 equal mu2, that means if it's equal, then we have to reject the hypothesis, the null hypothesis. But here it's not, it is different by looking at for the overall picture, and that reflects the impact. Is that exactly the because like how we can judge like if it's equal or not here?
Well, we really have to have for that. I may have an example with the actual data a little bit later, but we have to compare exactly what I said. We have to compare the confidence intervals, right? So we look at one case and say the upper bound, actually the other way is lower bound interval, upper bound interval for one to be disjoint, if you want, not overlap with lower bound interval and upper bound interval for the other, right? So in other words, if you are looking at the two averages here, and this is one confidence interval and this is the other confidence interval, the assumption that they are equal is rejected. That's what we are trying to do. So the assumption that mu1 equals mu2, or in other words, mu1 minus mu2 is 0, is rejected. So if I reject the null hypothesis, then the conclusion is, this is the conclusion: the two are not equal. However,
conclusion.
I may have the situation that is not exactly that. I may have the situation that these two, I'm going to try to put it on the same screen here, are like that. Here is the mean, here is another mean, but this is a big confidence interval, and here is another confidence interval.
They're
With
overlapped.
95%, right? If I make them smaller, maybe I can do them 68%. They may be smaller and they don't overlap, but because they overlap here, then I cannot reject the null hypothesis.
Oh.
I cannot reject the assumption that mu1 is equal to mu2.
Okay. Okay.
Okay, if this happens.
Okay. Thank you.
I hope everybody else gets this as well. And if you have other questions, please let me know. Okay, so moving on, we want I think this example here. Let me see if I have the whole data. I may need to take a very quick break, but let me see, maybe I can hold it. Yeah. So practically the fact that we have, actually what I mentioned here was exactly that. The travel time, because it looks at the standard deviation of 8.
Hypothesis, non-hypothesis.
Right.
An improvement lead to a travel time decrease. There is
standard deviation of 8 minutes.
There is no decrease.
And that's what we are looking at, right? So now it really depends on what you are I think in this slide is something that you don't have. I don't know why. Visible. Okay.
Unexplained variation.
A missing slide, I believe. I'm trying to find it, but
Conclusion.
This is
reject the non-hypothesis filter rejected decrease decision travel time.
okay. This has to do with the ability of the data information that we have, right? When we look at the yeah, definitely there's a missing slide. I'll have to put it back. I'm not sure exactly how it disappeared, so it's creating this constant discontinuity here in terms of the information. The idea is that we have
we have
the variables coming from the two distributions, coming from the before and after data collection processes. And we are looking at normal distribution.
The normal
distribution
and the normal distribution is
Just give me a sec.
Hello guys, how are you? I think the lecture is supposed to be like done right. I don't know if the doctor noticed that or not.
Okay, so I'm back in this case. I think we
今天上网课，我的摄像头，学生24个人，现在是课间休息，
have the
马上就要开始上课了。
null hypothesis testing based on the criteria that I mentioned earlier, looking at the confidence bounds and the ability to draw a conclusion based on the data we are collecting, and we generate those distribution parameters, that is averages, standard deviations, confidence intervals. There are different tests. I'm not going into too many details because this is already becoming a statistical analysis class. We don't want to do that. But the purpose here is to find out what is the suitable tool for your analysis. So the hypothesis testing comes with evaluation of what we call the t-statistics. The t-statistic is based on the normal distribution. Sometimes the distributions that we are, or the samples that we are comparing, may not have necessarily the same number of observations, and there are some other tests that you can conduct. But typically, when we look at the equal number of observations in the two samples, what the t-statistic will generate for you would be the results of a paired difference. So you are looking at the averages before and after, comparing the averages before and after based on that.
Same sample.
So when we're looking at sample observations, you have a certain number of observations and the same number of observations before and after. Looking at the average of the two pairs will give you, if you want, an average of the differences. And you can estimate we can estimate. Somebody had the question. What was the question? Just a second, I noticed something. Okay, in the previous slide, this 57.5 that we had earlier, that's why I said it's missing from another slide. I tried to look it up now, but I couldn't find it. 57.5 is information given. It's not the confidence bounds of your data, but the assumed, let's say, I'll find that slide and I clarify that for you. The assumed difference, I guess, for that particular distribution, the assumed confidence bounds. So back to this, you can do the t-statistics to find out the pair differences between the before and after observations, and we can estimate the standard error based on the formulas that you see here, and you can find out what is the standard deviation for that particular population, if you want, based on the standard error, right? You're using the standard error here divided by square root of n. And if we look at the calculated z value for the t-statistic, this really depends on the distribution that assuming to be normal. Practically, you would have to compare it with a value for a normal distribution that has the mean equal to 0 and average mean equal to the variance equal to 1. Mean and standard deviation, sorry, equal to 1, right? Mean 0 equal to 1. Basically, this means that the average is 0 and standard deviation is 1. For this particular distribution, the t-statistic has to be 1.645. Since we have to normalize it, we can call this the z value, and we normalize it by dividing it to the standard deviation, and we get 11.8. So as long as we get any value greater than the threshold for 95% confidence, and then we reject the null hypothesis. So calculating the z value basically for your distribution, which is not a distribution with the mean 0 and standard deviation 1, as it's this one, but normalizing it would give you the reference, the proper reference to draw the conclusion. Next slide, basically, if you don't have, do you have any questions? Oh, it's 5:40 already. Okay, time flew. Well, we have quite a few more slides to cover. I think it's, I'm trying to go over some examples, maybe more examples next time. I'll try to maybe allocate some of the time at the beginning to cover a couple of examples from here. And I have another maybe a suggestion for you. If you want, in the week coming, try to either get back to me by email or if you want to have conversations for office hours with specific questions regarding the past topics, maybe to look at some example problems that you think would be where you want to clarify specific other concepts than or concepts that are not straightforward if you are to review that material. So I'd give you maybe 1 week this coming week to review that material and send me to by Monday, let's say, some specific questions, and I can try to address them during the lecture together with the remaining part. Not many slides left, but a couple of examples that I would like to continue working with through here. Do you have any other questions?
So if I understand correctly, next week would be in order to get your final input when it comes to explanations, and then that's going to be it for the lectures?
Yes.
Okay, thank you.
Other questions? Some of you will see me a little bit later as well in the next class. No questions? Okay, anyway, email is still there. I haven't seen if you send me any messages. No, I don't have any messages here. but please let me know, as I said, and we can cover this. So I will try to set up by next week or so, finalize a quiz on Moodle, and I'll get back to you on when would that be due for you to complete it. Okay. So overall, I think this wasn't very demanding, I hope, for you to stay in front of the screen for so long. And we'll have maybe a few more weeks, right, as you know, until the semester finishes. For sure, we'll manage to complete the semester and have a proper conclusion of the course. If nothing else is
we need
yes.
your help in this, actually.
Sorry?
Help too much in this course to be finished peacefully. We need your help, actually, Doctor.
I'm trying my best.
Yeah.
I'm trying my best.
Or I'm the only one asking for help. I don't know. My colleague are all of them. Most of them are silent. Maybe shy.
Well, probably you addressed the concerns of some of other colleagues as well. So I don't know if there are other issues. Maybe I'll get a message from them and I can share them with
They are
you.
shy to tell something I don't know.
Actually,
I don't hear any of them. That's the problem.
Okay. So are there any questions, or we can conclude now the course? No more questions.
Please. Are you somebody's asking?
Okay, so if there are no more questions, I'll stop here, and we'll get back to this class next week. You have a link for office hours on Moodle, so you can use that, or send me an email if you want. Okay.
thank you
So
both.
be careful and stay put. Okay, don't get out too much, as you know. Okay. Bye bye.
Thank you very much.
Now one day it is like that. From the beginning, everybody was quiet. We didn't even see a face of anybody except the professor.
I think all the mics are on.
Yeah, you should stop speaking.
We can hear you.
今天上网课，我的摄像头，学生24个人，现在是课间休息，暂